This is just a quick video on the definitions from section 13.1. Okay. When you see an expression of the form z is equal to f of x and y, this is what we are calling an explicit function of z, and this is kind of additional, of z in terms of x and y. So I probably would just shorten that to explicit function. When you see an expression of the form g of x, y, z equal to c, where c is some constant, this is what I call an implicit function. Okay, implicit functions can be solved and turned into explicit functions, but when you see it in this form, that is an implicit function. Okay, so example here would be z is equal to x squared plus y squared. That's explicit. It's very easy to create a table of values for this. Take the x and y value, and then you can easily find the z value by plugging in. You'll get 1 plus pi squared. So nice and easy, explicit function. The x squared plus y squared, that is your f of x and y. As far as implicit functions go, we could take x, y, z is equal to 2, for example. So here, the x, y, z, that is our expression that has x, y's, and z's in it. And I have just multiplied each of the variables together to create an expression with x, y, and z and set that equal to 2. And here is your implicit function. Okay? Implicit functions, you can, let's see, so there's your x, y, z, and c and 2 is equal to your c. So this is of the form g of x, y, z is equal to c. In the book, you'll see implicit functions. You'll see another form of them, so let me just alternatively, let me prepare you for what's in the book. In the book, you'll see something that will just be of the form g of x, y, z, right? You'll see just something, and then they will pick some expression, in this case x, y, z. There's your expression in x, y, and z. Okay, so from here, we can introduce, so this is just an expression in x, y, and z, those variables. Okay, there's two other words that come out of here. You can say, if you take g of x, y, z and set it equal to some constant, right, which is what I was calling an implicit function or an implicit surface. So we can give this a name. You can call it implicit surface. It also has the name, it can also be called a level surface, or it can also be called a contour surface. So all three of those kind of go by the same name. So if you have an expression g of x, y, z is equal to x, y, z, right? You can take that expression x, y, z and you can put your favorite constant on the other side. You can pick 4, you can pick 2, you can pick x, y, z is equal to pi. Okay? In each of these, this would be level surface number 1. This would be level surface number 2, and similarly this would be level surface number 3. Okay, and so we know that each of these level surfaces could possibly be some sort of shape. This one could be over here, the level surface number 1. Over here could be another shape. This could be level surface number 2, and over here it could be whatever it looks like, level surface number 3. So by changing this constant, you can get different level surfaces. So as an example of showing that when you pick an expression g of x, y, z, and in this case we'll pick x, y, z, and then you pick different constants over there and you'll get different surfaces. Each of those different surfaces for different constants is a level surface. To illustrate that, let me bring in just a Mathematica demo that I've already created, just to kind of illustrate that when you pick a certain constant you may get one surface, and pick another constant and you'll get another surface. Here's a demo I've created that I've picked an expression that has x, y's, and z's in it, and we've chosen x times y times z. And then in this demo you can see that I'm starting with the value c on the other side of 2. And here is, as I've said, so that's your first level surface. It could have different pieces to it, but there is your first level surface given by these 4 pieces. If you change the constant on the other side, you can see that the constant is changing on the right-hand side of the equation. And, the surface is changing. The different points that satisfy this equation change. Okay, and you can see there's a weird flip that happens there. Right. When they go negative, when the constant can be negative, that's allowed. You get different. Okay. If you zoom out on this function, there's a lot of the points. So changing the constant again, you can, oops, that's the zoom out, sorry. Changing the contour means to change that constant on the other side of the equation. And for each constant you get a different surface. Okay, so for this constant negative 2.9, the surface is made up of these 4 pieces. You change the constant to negative 2, and this surface, the level surface when the constant c is negative 2, is the level surface when c is negative 2 is made up of these 4 pieces. So that's it for the terminology, and watch the next videos for more examples on implicit and explicit surfaces.